Good. Welcome, students, in today's discussion. Remember, if you are new to the channel, you can recognize me as Mr. M.Patrick in the YouTube. So we are here to simplify mathematics, to make mathematics as simple as unit in our learning. So today we are going to focus on logarithms. Today we are going to focus on logarithms. Today we are going to focus on logarithms. Good. So I'll go direct to simplify, to give some of the laws of logarithms. Then we get into examples. Some of these units we'll understand more when we interact with the examples. So I'll just give some few guidelines on the laws that we are going to guide us as we are going to venture in the calculations of or solving out the logarithms. Good. So in this case, if so we can say if, let's say for the case if we have maybe a power m is equals to b, a power m is equals to b, then the logarithm of b to base a is m. So we want to show, in short sum, we want to show how we can apply this in logarithm. How do we now put this one in logarithm form? How do you put that one in logarithm form? Logarithm form, it will mean this b, it will be now log b, yes, log b to base a, log b to base a. When I say base appears down there. Then it's equals to that m that is in power form. Now it will become now is equals to m. That is now how we apply or put it in form of logarithm. So if it is this form, it will be log b base to a, you come this way, log b base to a is equals to m. That is how we put it in logarithm form. That is how we put in logarithm form. Good. Next, now let us focus on some of the laws of logarithms. Let us focus on some of the laws of logarithms. Laws of logarithms. Good. In laws of logarithms, we realize we can as well also prove something here. So let's say, for example, now if we have log, let's say we have log b, log to base b, ab is equivalent to, when it is this way, it means that this is multiplication. In logarithms, multiplication, we do what? We add. So we are going to split this. So how do you split this now? Just the same as to say log to base b, log a base b plus log b to base b. Good. So that is how it shows. So this is multiplication. So this is how you treat first in case you have been given in multiplication form, or it is this way. It means you are going to do what? To add. When you split them, you are going, the sign that will appear here, it will be what? It will be addition. It will be addition. Good. It will be addition. It will be addition. What about division now? So this was in case of multiplication. In case of multiplication, multiplication, that is how you do in logarithms. You do in logarithms. So you can just put somewhere in a bracket and say NB, when you have a log that is now you are doing what we call multiplication, it will be equivalent now to do what? You will do addition. It will translate to addition. But when we have now, what we are going to do next here, we are going now to show what? Let us show the division now. What about division? What about division? What about division, comrades? Because we are going to interact with this, and these laws are going to guide us. So let's say we have maybe log a divided by log b to base a. How can you do that? Now we want to do it maybe either addition or subtraction. I've said in division in logarithm, this one it will be subtraction. Now in subtraction it will be just log. It will be log a to base a small a minus log b to base a. That is very simple. You see now the sign I've put here is what? Is subtraction. Is subtraction. Is subtraction. Good. Now, what about if you have something like this now? Let's say now we have a power. Now we have power. So how can we solve something that has got power? Let's say we have log to base. We have log to base a power a, and then you put in bracket, we have power p. How can you treat that one? That simply means this power, you will move it, become the first. So it will be p log capital letter A to base what? To base A. To base A. Good, to base A. So you see, that is how you'll treat this. You just move this p, will start at the first. Then it will be p log A to base small a. Good. Then there's something I will wish learners you understand as we're going to venture more in my practical session now. You have to understand, so you can put somewhere NB. In case you have any letter or any value raised to 0, any value raised to 0 is equivalent to 1. So if I have 1 is the power to 0, even you can use your calculator. 1 raised to 0 is what? 1 raised to 0 is 1. For those who are new to the calculator, scientific calculator, I always tell them, just press 1, then there's that something on your calculator that has got something like this. So when you say, I'll press 1 or I press 2, then you press this on your calculator, then write 0, and then you put is equals to what? It will give you 1. So any value raised to 0 is what? 1. So just in case you'll get some in a scenario, like in the logarithm form, you'll get in a scenario that you have something like, maybe let's say log 1 to base a is equals to 0. Log 1 to base a is equals to 0. This one now, if you want to simplify further, it is a power 0. A power 0 is equals to 1. A power 0 is equals to 1. That is how we do that. Good. So that was just the laws to guide us in our session today, because we want now to do more of the examples in regards to this. But just know that multiplication will be adding, addition will be, division will be subtracting, and how we can treat the powers you have seen. That's good. So let's now get some of the examples. Let's get some of the examples. Good. Let's get some of the examples. Now, let's do some of the examples so that comrades can understand this. We are here to simplify this mathematics. Good. So example 1. Example 1. Example 1. Let's say example 1. Example 1. Example 1. Example 1. We'll solve an easy one. An easy one. So it will be, let's say we have been given solve for x, solve for x, solve for x, solve for x, given, solve for x given, solve for x given log a to base log 9, in short log 9 to base 3 is equals to x. Log 9 to base 3 is equals to x. How do you treat that? Very simple. Very simple. Just using the laws I've given out. Very simple. Now, you remember when I started introducing this something, I mentioned that if you have maybe a power m is equals to b, it's just the same as what? Log b base a is equals to m. You see, very simple. So the same case we treated this, we are going to treat here. So this one will be now what? It will be 3. Now solution to this will be 3 power x is equals to what? to 9. Equals to 9. Equals to 9. Now, what do you do now after that? After you have realized that, you have to make either, in this, you have to make the powers, when I say the powers, it's like the 3 power x, the unknown x there. So the powers, you make it the same when solving this, or you'll make the bases to be the same for you to solve the values of the unknowns here. Good. So that means what? What do we do? Now we have 3x power, 3 power x is equals to 9. Here, if the unknown is on the power form, it is on the upper part, make the bases the same. Or if the unknown is on the base, and the unknown is on the base, we make the bases the same. Now for this case, I can see x that we are looking for, it is on the power form. Now I will make my bases the same. How? What can I make the 3 here? Now I have 3 here. Now I want to look in a way that I'll look for factors in 9 that can make let us get the 3 power x, or look the same as 3 power x, or the factors that can result for us to get the bases the same. Now, factors of 9. I'll just come here. Factors of 9. What can I do to get power 9? 9. So I will start. When I get to 3 raised to power 2, automatically, I'll get 9. Because if there's no way 3 power 1, I'll get just 3. Then, 3 power 1. 3 power 1, I'll get what? 3. 3 power 1, I'll get 3. So 3 power 2. So you just look for the factors. You look for the factors for this to make it the same. So for this case, we have already gotten the answer to be this one. So it will be 3 power x equals to 3 power 2. Meaning this 3 power 2, if I simplify it further, it can just come back to 9. So this is just the same thing. So we have already made the bases the same. So I will just cancel off. If 3, I cancel off. Meaning the unknown there is what? 2. Very simple. Very simple mathematics, and that is how we do that. Let us now do another one. For this case, I want this unknown to be on the base. Good. So example 2. For the bases are now on the base. They are not on base that we are looking for. Good. So example 2, solve. We have log. 8 to base x is equals to what? 3. 8 to base x, log 8 to base x is equals to 3. Good. The same thing, we are going to treat this one here. Here. Now, how do you treat this? The base power to this. So it will be x power 3 is equals to 8. Very simple. X power 3 is equals to 8. So if x power 3 is equals to 8, now we have to look for factors. Look for factors of 8. I will just start. Very simple. Now I can see on the upper part I have 3. So I will just make it very easy. I want to make, here we are making bases, powers. We are making powers same. Remember here we make the bases same. So here we are making powers same. Because the unknown is on the base. So it will be what? Factors of 8. Here 2 here. 4. No, it won't make it. It won't work out. 2 multiplied by 2 power. Maybe if you say 2 power 4, it will be what? 2 power 4. 2 power 4. It will be what? It will be 16. It has gone beyond. Let us now put 2 power 3. 2 power 3. So 8, let's say now 2, 3 here. 2 power 3, it will be what? 2 power 3 to give us 8. So it is very simple. I will say x power 3 is equals to 2 power 3. Good. Now you can see how make the powers same. Powers are the same. You see? So it means because we want the aim here, we want to find value of x. And if your powers are the same, you just cancel off. Very easy. Now you have your x as 2. Understood? Good. The first one you can see the we were able to, the bases that were the same and we were able to cancel them. We get the power. But here, we are making the powers now the same, we cancel them. Wonderful. Good. So, feel at home. Enjoy the lesson. I know we are going to make it easy for you and you're going to learn more on this. So, we have another example here. We have another example. Let me give you this. Very easy one. What about if you have maybe, let me give you this one example, maybe example 3. Example 3 on log. Example 3 on log, we have log. Log x. Now, 2 base 2 is equals to 3. Equals to 3. Just apply this. Apply this. Underline my word apply. Apply this, the one I started with. A power m is equals to b. If I put it in logarithm form of this, it's what? Log b to base a is equals to m. Equals to m. So this is what we are applying here. For this case, it will be what? It will be 2 power 3 is equals to x. 2 power 3 is equals to x. Meaning what? Our x here will be what? So it will be x is equals to 2 power 3. 2 power 3. So our x in this case, it will be, our answer here, our x, it will be what? 2 power 3 is what? 2 power 3 is 8. 2 power 3 is 8. Oh, 2 power 3 is 8. So my x is 8. So that is how. Just apply this and you are good to go. You are good to go. Good. You are good to go. Now, let us now venture into something else. Okay. Let us apply one that now we have to put the, how we apply in case we have the powers. The value, to find the value of a known, now that the unknown is on the base. The known is on the base of a logarithm. Good. Good. So, let us solve now this one. Let us solve this one. And very nice one. What about if you have, so this is our example what? Or our illustration 4. Illustration 4. Illustration 4. We have now, there's something here very wonderful, which I want you to, in case you find it, you can do it. So we have log 25 to base square root of a. Remember, we are solving for unknown. Is equals to what? Equals to negative 4. Equals to negative 4. How do you see that question? Here we are finding unknown. We'll find unknown. Unknown there is what? Unknown there is a. How do you get that a? You see, very easy. Just apply this. Learner, just apply this. Don't run away from this. A power m is equals to b. And when you put it in logarithm form, it is log b to base a is equals to m. So just apply this here. Don't get worried with this square root down here. It's very simple. So how do you do that? Then, if I apply this, it means it will be a root a power what? Root a power negative 4 is equals to what? 25. Very easy. Very easy that way. It's equals to 25. Good. Now, I will proceed. Now next, I will put this one to power. 25 to power. 25 to power, I will square it. Good. Now it will be root a to power negative 4 is equals to 5 power 2. Good. 5 power 2. Meaning my aim here, I have to make sure that the powers are the same. And how do we make powers the same? Now, it's very easy. How do we make powers the same? Here? Good. So, learners, we realize the square root of this, the square root of this, it can be the same as, just the same as a power a half. A power a half, in bracket, outside we have negative 4. A power half, in bracket negative 4. A power half in bracket negative 4. So when we do now we solve this further, it will be here 1, here 2. So the answer here will be in bracket a power negative 2. A power negative 2. A power negative 2. A power negative 2. Good. So at the end of the day, we will be having a power negative 2 is equals to 5 power 2. A power negative 2 is equals to 5 power 2. Equals to 5 power 2. So we are heading somewhere. Our aim is to make sure our powers are the same. Our powers are the same. Good. Our powers are the same. Now, so I will go ahead, just very simple, to make my powers the same. It will be, now I'll put this one, it will be a power negative 1, outside I put 2, is equals to 5 power 2. Very wonderful. I love this. I always love science behind mathematics, this units to do with business mathematics. Good. Now, let's proceed. Let's proceed. Now we have made the powers the same. What next? We remember we said when the powers are the same, we do what? Powers are the same. When the powers are the same, we do what? We cancel off. The powers are the same, we do what? We cancel off. Now, I can see here I have 2 there. So I will cancel off. Then I will remain with a power negative 1 is equals to 5. A power negative 1 is equals to 5. A power negative 1 is equals to 5. Remember, there is somewhere in lots of indices, we said if any value is raised to a negative. Now, like this case, we have negative there. If any value raised to negative, it's just the same as to say it is equivalent to 1 over a. 1 over a. 1 over a. So for this case, it will be here, very easy, 1 over a. 1 over a. 1 over a. So 1 over a is equals to 5. Now to find the value of a, it will be what? You cross multiply. You cross multiply. If you cross multiply, it will be now 5a is equals to 1. To find the value of a, it will be divided by 5, divided by 5. So a, in this case, our answer here, a will be equals to what? 1 over 5. Good. Very easy, step by step, and you understand it. Very easy. Good. We are still on logarithm. I want us to exhaust that logarithm fully. I want us to exhaust this fully so that we cannot get in doubt. So what if you have now, let us put now our example 5 here. Example 5. Now example 5, we are still finding values of unknown. We're finding the values of unknown. We are still working on the values of unknown. We have 2 log 3 to base x is equals to what? Is equals to 4. Good. Now you see we have 2 here. Now if you have 2 there, it is simply means it will be equivalent to log 3 power 2 base x equals to 4. So you see we have moved this 2 to power now. You see, just the same as that. Just the same as that. Good. Now if you have that, what next? If you have that, so it will be just the same as log 2 squared 9. 2 squared is 9. 2 base x is equals to what? 4. Then we apply our rule here. We apply our rule here. This rule here. So we apply that rule here. We want to apply here. So it's just the same as now to say x power 4 is equals to 9. X power 4 is equals to 9. Meaning we have to make sure that we make now we make sure we make the power form to be the same. How do you make now the power form to be the same? Now that you have, it's very interesting question. X power 4 is equals to 9. How do you make it the same? Very easy. Don't get worried, because I know if you get the factors of 9, there's no way you'll get 9. Because 9 squared, to get that one, you know, it will be squared. At least you get a square. How do you get square now? This one is very simple. Now I will treat this one. I will look at x squared, x power 4. I can put x power 4 is the same as to write x power 2 in bracket 2. Meaning x, if I multiply x by 2, 2 by 2, I'll get back to x power 4. Very easy. Now it will be equals to 9. And 9 squared, to get powers or factors of 9, it is 6 squared. Good. Now if you have that, it is very simple. it will be x power 2 in bracket 2 is equals to 3 squared. You see how we have made the factor, the powers the same? Meaning we are going to do what? Now cancel there. We are remaining with what? We are remaining with x squared is equals to 3. X squared is equals to 3. Remember, how do you treat x? How do you treat square? How can you remove a square? You square root both sides. Very easy. When you have this, you just square root to remove this. Now we have x squared. To remove x squared is equals to 3. You remember, anywhere if you see a square and you have to eliminate it, just square root both sides. So if you square root both sides, I square root both sides. So my x will be the square root of, so any plus or minus square root of 3. So if you go on your calculator, find the square root of x here, it will be plus or minus. When I say plus or minus, I mean if you get the square root of any value, square root of any number, square root of any number is equivalent to plus or minus the answer you'll get. So meaning we'll have two values of the answers of x here. Good. So I was just trying to do those that seem to be very technical. I started with this one here. This one seemed to be technical, but just follow those one because this rule will be guiding you all through. Good. Now let us do one that regards to addition and subtraction. Addition and subtraction. How can you treat now in logarithm form addition and subtraction? Good. Let us just at least do 2 or 3 solution. 2 or 3 solution. Good. Good. So we are on addition and subtraction in case of we get it in an exam. So I will start with the addition. I will combine. I will start with the combination of the same addition and subtraction. Remember, when I told you when you see subtraction in a logarithm form, it means you are going to divide. You're going to divide. Good. You're going to divide. So let's see how we can treat now addition, and subtraction in logarithm. Subtraction in logarithm. Good. A logarithm form. Logarithm. Finding unknowns. Logarithm. While you have addition and subtraction. First, illustration 1. Illustration 1. Illustration 1 comes here. We have log 45 to base a minus log a log 36 to base a, then plus log 20 to base a is equals to what? Equals to 2. So there we are finding which unknown? We are finding a, the unknown a. So remember I said when you see minus, we do what? You divide. And when you see addition, you multiply. Good. So what next? Now the bases are the same. You see, the base a, base a, base a. Meaning, if the bases are the same, you do what? It will be equals to log base a in bracket. Now, the first one you can see it's a minus. Meaning, it will be 45 divided by 36. Here it is addition, meaning multiply. Multiply by 20, close the bracket, is equals to 2. Equals to 2. Body mass, we start with which one? Division. In body mass, we start with the division. Good. We cannot run away from basic. I always say, just stick to the basics. And these things will be easier for us. Now, if you divide that, 45 divided by, you'll start with that, 45 divided by 36, what do you get? 45 divided by 36, I get 1.25. 1.25. 1.25 multiplied by 20, I get 25. I get 25. So it will be log to base a in bracket 25. 25 is equals to what? 2. Equals to 2. Now, after that, it means we go back to our first law. this one, it was leading us. This one now, we apply this one. A power m is equals to b. So you'll say, and we say this one is log b to base a is equals to m. Is what now we want to apply here. It's what we want to apply here. Now, it will mean it will be a power 2 is equals to 25. A power 2 is equals to 25. Now, when you are back, you are here now, it's very easy for what we have been doing. We make now, because the unknown is on the base, we make the powers the same. So we look for the factors of 25. Factors of 25 to get 25 is what? 5? 5 squared. Factors of 25, you get 5 squared, you'll get 25. So the powers of 25, it will be now, you'll come and say a power 2 is equals to 5 squared. 5 squared. And remember I said when the powers are the same, you cancel off. So we are just going to cancel here, and our answer will be a is equals to what? 5. A is equals to 5. And you are good to go. That's how we treat addition and subtraction. Good. Let's get another one at least so that we can enhance our understanding more on the same. What about if you have now maybe the unknown is in between the figures? Now, let's do this one. It's a nice one. Let's do this one. Very nice one. Very easy. So let's say illustration 2, illustration 2, illustration 2, illustration 2. So illustration 2, we have log to base 2 in bracket 3x plus 4, close the bracket, minus log 2 in bracket x minus 2 is equals to 3. Equals to 3. Now, how do you do this? Now, very easy, very easy. What do you do? It will be now, because the bases are the same and we have subtraction there. Subtraction means we are dividing. So not this one. Subtraction, you are dividing. Addition, you are doing multiplication. So it will be, because bases are the same, it will be log base 2, 3x plus 4, you divide by x minus 2 is equals to 3. If it could be multiplication, I could have multiplied this by this. But because it is divided by subtraction, it means what? We divide. Now, if we divide using this law, this one now, don't run from this. It will help you. Now we apply here, it will be 2 power 3 is equals to 3x plus 4 over x minus 2. X minus 2. Good. So, what next now? 2 power 3 is what? 8. 2 power 3 is 8. So it will be very easy for us. Very easy for us. So it will be 3x plus 4 divided by x minus 2 is equals to 8. So just do cross multiplication. Very easy. So you'll come now, do what? 3x plus 4 is equals to, in bracket 8x minus 2. That way, very simple. So you go ahead and calculate. So it will be what? 3x plus 4 is equals to 8x minus 16. 8x minus 16. Good. So you collect like terms together. 8x will come this side. So it will be 3x minus 8x equals to negative 16 minus 4. Good. So it will be here 3x minus 8x, negative 5x. So it will be minus 5x is equals to negative 16 minus 4. It is negative 20. Negative 20. Find value of x. You divide both sides by negative 5. Divide both sides by negative 5. So our x there becomes what? 5 divided by 20 divided by 5, 4. So you get your answer. So you see, it's very easy. It's very easy. It's very easy. Good. Now, so I want to give you some questions you try on the same. You try on the same. Then, where you might get a problem, you will ask in our main discussion, or when we meet in maybe in our various discussions which we conduct on weekly basis, you will be able to raise. So I will give out a assignment, which I will love if you subscribe to the channel. I know I will do the solution for the same in the next video. In the next video. Good. In the next video. Good. So I want us to have assignment. I want us to get the 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 assignment. And the assignment reads, you can write somewhere if you are listening very careful. The assignment reads log to base 10. When I say log to base 10, just the same as to say log. When I just leave that one without even writing 10, it means it's log to base 10. So you have to know that. So log, that one in bracket 7x, bracket 7x, in bracket 7x plus 1, close the bracket, minus log, in bracket 9x minus 5 is equals to 0. Equals to 0. Here now you remember I said any value, let's say 1 raised to 0 is what? 1. So any value you get raised to 0 is 1. So that one I know that is what we made there. Another question I want you to go and try. Solve. Find the value of unknown. Log. Find the values of unknown. Find the values of unknown. We have go and find log 75 plus log 9 plus log 5. You divide by log 75 plus log 9 plus log 5 divided by log 5 plus log 45. Find the value, solve that one. We get the answer. Log 75 plus log 9 plus log 5 divided by log 5 plus log 45. Good. So learners, that was a logarithm. I think we have followed it very keenly, and we have tried our best to explain it in a way we can simplify this calculation. So if you have any comment, you can drop it in my comment section, so that when I'll be going through, I can see where you need maybe for me to clarify. I'll come and clarify. So, and if you have any question, just drop in the comment section, and remember to subscribe to the channel and share out so others can benefit. For today, bye bye, and may God bless you.